Hello, sixth graders. This is Mrs. Dubé coming to you from room 21, and we'll be exploring lesson 10.5 this evening or this afternoon, area of a trapezoid. So I know you don't have this in front of you, but we're just going to look at a couple of things before we get started. Don't let this big, huge formula scare you. It's very similar to what we've been using. If you notice, the B's would stand for bases, and we have the height, and then we just have a fraction of a half. So the area of a trapezoid is half of base 1 plus base 2 times the height. I'm just going to show you a couple things to try to explain this. So a trapezoid looks like this, and it's at each of the tables you sit at school. Each of your tables are a trapezoid. Each of your tables is a trapezoid. Weird. Okay, so a trapezoid is a trapezoid because it has one set of parallel sides. We've been talking about parallelograms. They have two sets of parallel sides. Well, trapezoids only have one set of parallel sides. Okay, so the top and the bottom are the parallel sides on this trapezoid, and they also refer to the bases. So one would be base 1 and the other one would be base 2. So that's where we're getting the base 1 and base 2 in our formula for area of a trapezoid. So remember, the bases, the parallel lines will be the bases of our trapezoid. The other thing to remember is that two trapezoids, if you turn one, flip one around, two trapezoids make a parallelogram. So if we flip that around and then we pretend this line does not exist, you can see here we have a parallelogram. Okay, that's important to know as we explore the formula for areas of trapezoids. So looking down here, I have this parallelogram over here, and we know the area for a parallelogram is area equals base times height. Okay, so any parallelogram can be divided into two trapezoids. Okay, so I'm just going to move one of these out of the way. Okay, so a parallelogram can be divided into two trapezoids. So here's the parallelogram, and they can be divided into two trapezoids. Let me just move that out of the way. So there are two trapezoids. Now, when they're together, let me find if I can find my white line again. Where did it go? Okay, so anyway, we'll move this together. Pretend that black line isn't there. This is one of our bases of the trapezoid, which is the same length as this base. And then this base of this trapezoid is the same length as this base. Okay, so you can kind of see the similarities. So this trapezoid 1, we'll call it, is the same exact area as this trapezoid 2. And this blue line, the longer base of trapezoid 1, is the same length as the longer base of trapezoid 2. The shorter base of trapezoid 1 is the same length as the shorter side of trapezoid 2. Okay, so just to keep in mind, and this will help you when we're learning about our formula for area of a trapezoid. Now remember, when we're doing this, especially when we're looking at parallelograms, whoops, trying to get the red one off of there, remember our dotted line always represents the height because it's dotted and it makes a 90-degree angle with the base. It can either be the top base or the bottom base that it makes a 90-degree angle with. And that always equals our height, even when we're doing the trapezoids. So let's take a look at lesson 10.5. Essential question, can you find the area of a trapezoid? Any parallelogram can be divided into two trapezoids with one pair of parallel sides that are also the same shape and size, which I just showed you on the other slide. The bases of the trapezoids, and we call them B subscript 1 and B subscript 2. You can see a little better up here. Okay, so they're kind of like the opposite of exponents because they're lower, but they don't do what exponents do. They're just labeling. This is the first base, this is the second base when we're talking about a trapezoid. So the bases of the trapezoids B1 and B2 form the base of the parallelogram. Okay, so this is what we were just talking about. Remember I said the reds are the same length and the blues are the same length. So each trapezoid, so here's the first trapezoid, has a red length and a blue length, or a base 1 and a base 2, and it's the same on the other one. Okay, the area of each trapezoid is half the area of the entire parallelogram. Okay, so we have this entire parallelogram right here. Pretend all those dotted lines aren't there. It just looks like a parallelogram. And a trapezoid is half of the parallelogram. So this area will equal this area. Okay, so the area of a trapezoid is half the product of its height, product means multiply, and the sum of its bases, sum means add. Okay, so here is the area of the trapezoid. So again, it's half the product of its height. So here's the height, and the parentheses means multiply. So here's the product of the sum, here's the adding, of its bases. So I'd like you to pause the video for a minute and just study that formula and see if it makes sense. I know it looks very busy, but it is quite simple. So take a minute to look at that and absorb it. Okay, great. So if you need to pause the video, go ahead and pause it. So this is the new formula we're going to be working with. And again, we're just going to be plugging in. Remember, B subscript 1 just labels one of the bases as base 1. And B subscript 2 just labels the base of the other base of the trapezoid. And H is just the height, which we know is the dotted line. And half, we know we can either use half or 0.5, whatever makes us the happiest. All right, so moving on to unlock the problem. Mr. Desmond has tables in his office with tops shaped like trapezoids, much like we have in our classrooms. The diagram shows the dimensions of each tabletop. What is the area of each tabletop? Okay, so the first question over here says, how can you identify the bases? Well, back to the first slide, if you need to rewind, go ahead. We said it's the two parallel sides. Those are the bases. And how do we identify the height? We identify the height, usually it's dotted, and it forms a 90-degree angle or a perpendicular, I'll just put perpendicular angle with the base, or one of the bases. Okay, so you need to know that. This vocabulary you need to know, or you're not going to be able to keep up with this. So if you need to pause it, go ahead. So right away, we can just call this base 1 and this base 2, and this is our height. So wow, already we know what to plug in. So find the area of the trapezoid. Okay, so step 1, write the formula. Where have you heard that before? Then we're just going to substitute 1.6 for base 1. So here's base 1. Here's base 2. We're going to substitute 0.9 in for base 2. And then we're going to times it by 0.6 for the height. Okay, so base 1, base 2, and height. And now we just use our order of operations. Okay, so add within the parentheses. So first we have to add 1.6 and 0.9, and we get 2.5. Okay, and now we have 1/2 times 2.5 times 0.6. And we know with the commutative property, we can multiply those three numbers in any order that we wish. So sometimes it's easy to take half of an even number first and then multiply it by the other one. But in this case, we'll just multiply 2.5 by 6/10, and we get 1.5. And then we have to take half of that, which would equal 75 hundredths. Okay, or if you think of this as $1.50, half of $1.50 is 75 cents. So the area of each tabletop is 0 and 75 hundredths meters squared. And remember, we know its area when our units are squared. Okay, go ahead and pause if you need to review that again, or if you need to catch up. If not, let's move on to example 1 on page 558. Find the area of a trapezoid. Write the formula. Don't forget your box of goodness. Whoops, I forgot it on the other one. I'm just going to write it right here. It's a little boxy here. We're going to need an A for area, a base 1, a base 2, and a height. Box of goodness, I can't believe I forgot that on the other one. I'm so sorry. Okay, so we're going to substitute in or see what we know. Okay, so the area, it looks like we're finding the area, so that's just going to stay A. Let's call base 1 the 4.6. And this 4.6 is parallel to 9.4, so that's how I know those are my bases. And my height is the dotted line that makes a 90-degree angle with one of the bases, so I know that's 3.5. So now I'm just going to come over here and substitute in. So A stays A. 1/2 we just bring down. Base 1 is 4.6. We're just subbing in for base 1. Base 2 is 9.4. We're just subbing in for base 2. And then times the height is 3.5. So we're subbing in the 3.5 for the height. And now we have to go ahead and find the sum of the two bases first. Okay, so when we do that, we get 14. All right, now I'm going to take half of the 14 first because I know half of 14 is 7, and I'd rather take half of 14 than half of 3.5. It's just me. Maybe you enjoy taking half of decimals. That's fine too. Odd decimals, you know, whatever floats your boat. So 1/2 times 14 would be 7, and then I'm going to go ahead and multiply 7 times 3.5, and I will get 24 5/10. So the area of this trapezoid is 24 5/10 centimeters squared. Okay, so example 2 is the trickier one. It gives us the area, we have to find the height. So of course we start with writing our formula and our box of goodness. So remember, they're giving us the area and they're saying it's 702. Okay, base 1 we'll say is 20 inches. Base 2 we'll say is 34 inches. And the height is what we're looking for. So that just stays the height. Okay, so we're going to substitute in. We have 1/2 times 20 plus 34 is in our parentheses. And then our height is what we're looking for. So that stays H. Okay, and plus we plugged in 702 for our A. Great. So now we do 702 equals 1/2 times, we have to add the 20 plus the 34, which is 54, times the height. We're still looking for the height. Now we go to the next step, 702, so we have to do half of 54, which is 27, times the height, which we're still looking for. And of course, we know to get H by itself, we're going to divide each side by 27, right? So 27 divided by 27 is 1. 702 divided by 27 is 26. So our height is 26 inches. Go ahead and pause that if you need to and look at it one more time. It's the same exact thing as we've done before. It's just with a different formula. And if you can remember that your bases are parallel and your height is perpendicular, you'll be in perfect shape. So please, for tomorrow, I'd like you to do the share and show, number 2. And if you go down to the on your own, number 6. So this one you're finding the height, so it already gives you the area. Okay, good luck everybody. Take your time, rewind if you need to, and we will see you on the flip side. Have a great night.